Okay, so today, what we're going to do is this. Okay? We are going to stop talking. We are live and I'm recording. We're going to take these graphs. We're going to take these graphs that we learned about just about 10 minutes ago, and all we're going to do with these graphs is we're going to move them. That's all. So if we take a look at problem number 1, we've got x to the fourth. Well, I know what x to the fourth looks like. It's this graph right here. That's x to the fourth. And then all we're going to do is take this graph, x to the fourth, and we're going to just move it down 9. Now, it doesn't have to be perfect from you, okay? You just need to have the right general shape. So if I were to go ahead and put my xy axis in there, go like this, right? Go like this. And I'm going to go down 9. So I'm going to go probably, let's see, go by 2's, negative 2, negative 4, negative 6, negative 8. So negative 9 is right about here. Now again, I don't care if it's perfect. It just has to be the right shape moved correctly. So again, I want the right shape and I want it moved correctly. I know that the y to the fourth looks like this. So I'm going to take this graph and just drag it down 9. So my graph's going to look something like this. Okay. I just took my x to the fourth and I just drug it down 9. Okay. That seem easy? All right. Number 2. Am I going too fast? Number 2. So look at 2, x to the fifth. Okay, that's this graph, right? That's this graph, x to the fifth. And I'm going to take x to the fifth and we're going to move it to the left 1 because the opposite. And then I'm going to go up 2, right? Always the opposite inside. So what I notice is within the x to the fifth, it has a little bend right here. That's called the inflection point. Remember we talked about that? So I'm going to move this inflection point really over 1 and up 2. So I'm going to put my axes in. Okay. My axes in. And I'm going to take and put my inflection point right there. Okay, so take my inflection point and put it there, and I know the shape looks something like that. Okay, I moved it left 1 and up 2. All right, let's do number 6. No, we'll do 3, then we'll do 6. Let's do 3. Okay, let's do 3. X to the 6. If I go to my graph, x to the 6 looks like this, right? That's what it looks like. Is that one there? We're going to take x to the 6th, and we're going to make it upside down because of the negative. And then we're going to move it to the right. And then we're going to move it to the right 2 because we're going to the opposite. So I'm going to take my x to the 6th graph, which is there, and then we're going to take that graph, we're going to make it upside down, and we're also going to make it 5 times as tall. Well, that's going to be kind of hard to tell, 5 times as tall, but we will definitely see it being much steeper, okay? So I'm going to go to the point 2, 0. It's right about there. It's going to go upside down and super steep. That's not even a very good graph of it, but there it is, okay? It's upside down. And again, I don't care if it's super accurate as long as it's the right shape in the right place. Does that make sense? All right, let's do number 6, and then we'll turn the page, okay? Number 6. Am I going too fast?
No.
Okay. So it's next to the 5th. So again, I look at this, right? We don't want to lose this. So x to the 5th looks like that, right? So it has a little inflection point. So what I'm going to do with that is we're going to take it and move it to the right 10 and then up 1. Well, if I have to go to the right 10, probably better put my axes way over here, right? And I might even need to go by 2's. 2, 4, 6, 8, 10. So my inflection point is going to be right there, because I want to go to the right 10, 1. So I know my x to the 5th looks like that, right? There's my x to the 5th. I'm going to put that graph right there, okay? So it's going to look something like that. Again, doesn't have to be perfect, but it does have to be in the right place and the right shape. It doesn't have to be perfect, but it has to be in the right place and the right shape. So you definitely want to hang on to this, right? Until Friday, right? Until the end of Friday, right? Okay. Thumbs up. Okay, let's turn the page. Right? All right. All right, number 7. So, I don't think I want to do 7. I want to jump all the way down to probably 10. How about 10? And then I'll be done. Okay. Let's look at 10. Okay, you guys see 10? Okay, number 10. So let's take this function and let's translate it to the unit, 1 unit left. So it's got to be inside. So inside, we're going to go in x plus 1. Okay? Inside, x plus 1. Because remember, it's always the opposite back and forth. So if I go right or left, it's inside but the opposite. Remember that? I'll say it again. I'm going to go left, it's going to be done inside, and it's going to be the opposite, okay? Followed by a reflection of the x-axis. Reflection of the x-axis means I need to make it a negative f of x, and a vertical stretch by 2. So I'm going to make it twice f of x. Okay, let me put all of that together, okay? Here's my stretch, twice as big. Negative is going to make it upside down. And the x plus 1 inside is going to make it go back 1. So if I take this, first of all, I'm going to go a negative 2 times, in fact, let me go ahead and use a bracket, okay? Okay, negative 2. Here's my negative 2. Here's my negative 2, okay? Now I've got to put, okay, the negative 2 is make it twice as tall and upside down. Now I've got to put this inside. Where does it go inside? It goes inside the x's. It goes inside the x's. So I'm going to have a x plus 1 cubed minus a 6 times an x plus 1 squared plus 5. Now, my guess is if you do a problem like this, they're going to want you to simplify it. I'm not. This is enough. Okay? This is enough. You agree? Okay. So, you have an assignment loaded up, okay? And